In this video, I'm going to be showing you how to recognize functions by their graphing characteristics. This is a continuation from part 1, which can be found in the link in the description. Now, a recap. We know that linear lines have no max or min, and they are a straight line. These are the characteristics of a linear function. For a quadratic function, we know that it is a U-shaped function. So the graph looks like a U, and there is an increase and decrease within the graph. And then finally, we have exponential. Exponential functions also do not have a maximum or minimum, and they are made up of a smooth curve. We're going to use these three definitions to help determine the graphs. This line, how can we determine what function it is? Well, first we need to make a note that we see arrow points at each end of the line, and I should have arrow points at the end of my graph to signify that these lines are continuous. So if there were bullet points at the end, this line would stop. But since there are arrows, it continues infinitely. There is no stop to this. But now we can see that there is no maximum, nor is there a minimum on this graph. We're also able to see that this is a straight line through the origin. If you don't know what the origin is the center of the graph located at 0, 0. Line. This function, well, right off the bat, we can see it's continuous and it's a straight line. There's also no max or minimum because this line is continuous. So we are able to say that this line is also a linear function because it matches up with our definitions, which means there's a straight line and it has no maximum or minimum. Let's take a look at this function. This function is the same one as we just shown, it's just on the y-axis. This is a straight line, and there is no maximum or minimum, and it is continuous, so we know that this is a linear function. Let's take a look at this function. This function is not like our linear function. Right off the bat, we can tell that there is no straight line, and there is an absolute minimum. Using those two, we can right off the bat know, hey, this is a quadratic function, but need you more evidence? Here is the increase and decrease. I've drawn those arrows there to show that it decreases along the line, then increases. So we have our U shape and our increase and decrease, or decrease and increase. Either or works. Taking a look at this function, we can see that it is just flipped across the x-axis. We are also able to see that U shape again, but in this case, it is a absolute maximum. We can also see that this function increases, then it decreases. So it has to be a quadratic function. This function has no maximum or minimum. And this function is not a straight line. This function is also not U-shaped. Let's try to imagine a square. And in this square, we rounded off the edges. But we zoomed in on the bottom right portion of this square. And that is what we have, a smooth curve. So this function is exponential. Taking a look at this function, we're able to see that there is no max or minimum. We're also able to see that it is a smooth curve. Again, imagine the square, and in that top left corner this time, this is why it's an exponential, because of that smooth curve. I want you to try and complete these 3 problems. So pause the video, write down your answers, and we'll go through them together. Looking at graph 1, right off the bat, we are able to see that U shape. We're also able to see the increase and decrease within this graph. I find it best to trace the graph to show the decrease that then leads to the increase. This is textbook to our definition of a quadratic function. Question 2, we see it's a smooth curve. We're also able to see that there is no maximum or minimum. And we can see that it's only decreasing along the x-axis. So this has to be an exponential function. And finally, for question 3, we see it's a straight line and that there is no maximum or minimum. So this function has to be a linear function.